Hello everyone, welcome to our aTech channel. Today we're going to talk about the reality of home wind turbines. We've seen wind turbines popping up everywhere in the last few years, although they're mostly installations for the general grid. For electricity production from home, solar energy has always been preferred. But what if it is possible to install wind turbines on one's house? Obviously the size would have to be scaled for it to work. In theory, it seems like a good idea to diversify your electrician production. But does it make sense to install micro wind turbines in your home rather than just installing solar panels? From a resilience and independence perspective, it makes sense to diversify your energy sources. For example, your wind turbine could continue to produce energy in the middle of the night while your solar panels would not. In the race to develop green energy, wind power is becoming increasingly popular around the world. In fact, electricity generated by wind power has increased by 170 terawatt hours, which is 11% increase by 2019 and 2020. Excluding hydropower, wind power becomes the world's largest renewable energy source, and for good reason. It generates 1,592 terawatt hours of clean electricity each year, even though this is almost exclusively at grid scale. The obvious question is, why not make the wind turbines smaller so they could be installed on our homes? Wind turbines typically have huge rotor blades about 50 meters long. The longer the rotor blades, the more energy the turbine can generate from the wind speed. This means that a micro wind turbine will generate much less energy than a conventional wind turbine. In larger wind turbines, there is a control mechanism that adjusts the angle of the blade to harvest more energy. Then, inside the nacelle, which is the main body of the top of the tower, there is a gearbox that converts the lower speed rotation of the blades into higher speed. This allows the generator to be driven more efficiently. There are also rotor blades for safety purposes, an anemometer for measurements of the wind, and a wind turbine orientation control system. All of these systems work together to optimize performance and prevent the wind turbine from self-destructing. There are a lot of so-called moving parts, and that's on a large scale. So how do model turbines perform? Micro wind turbines typically produce up 400 and 500 watts, but can go up to 10 to 20 kilowatts. It all depends on the application. Their blades are often 1.5 to 3.5 meters in diameter and are made of synthetic metals. Most often they're made of carbon fiber reinforcement polyamers to make them stronger and light. While large-scale wind turbines have active steering systems and electric pitch control, small wind turbines use passive steering systems and mechanical pitch control, or no control at all. They're much more simplified, but they still have moving parts. Depending on the model, small wind turbines can produce either direct current or alternating current. Just like solar panels in your home, you need to install DC to AC converter to use direct power through the AC outlets. Adding an energy converter to this system reduces the overall efficiency. This is a minor inconvenience, but worth noting. You should know that wind generators are classified into 3 types. Whether they are large or small scale, horizontal axis turbines are the most common type that you'll all know. They operate horizontally, rotating the top of the tower so the blades face the wind. Another type is the vertical axis turbine that is perpendicular to the ground. They are also wind turbines that installed without moving parts. If there are many installations, small wind turbines seem to be a great option for decarbonizing homes, as is adding solar panels. You may be able to sell your excess energy production to an energy provider, generating additional income. Immediately, the reasons to install wind turbines at home are the same reason for installing solar panels. That is, to reduce dependence on fossil fuels and avoid the problems of rising energy prices over time. However, there are several disadvantages that we must take into account. First, the wind does not blow all the time. In fact, macro wind turbines only operate around 30 to 40% of their capacity. If the turbines are installed on a roof, they can vibrate, causing noise and potential structural problems. Noise from the blades, even in small wind turbines, can be the order of 50 to 60 decibels. There is also height to consider. The average recommended height for a small wind turbine is 20 meters, which is quite high. Any lower quality turbine can be affected by nearby buildings or trees, which could disrupt the wind path. On top of that, many subdivisions do not allow such high structures. Thus, wind power makes more sense in more rural locations where none of these points are an issue. Unstable wind flow can cause turbulence, which will disturb the turbine components and can affect the wind measurement by a nanometer. This can lead to safety issues, as the control system will make inappropriate decisions based on incorrect wind speed. There's also operating and maintenance costs to consider. If you buy a residential wind turbine for 10,000 euros, you can expect to spend about 300 euro per year to maintain your turbine. If you compare this to solar, there is no maintenance since there's no moving parts. If your 1 kilowatt turbine experiences an average wind speed of 4 meters per second, it'll produce about 100 watts, which is only 10% of this rate capacity at that speed. This is an excellent backup energy source. Thus, several companies have tried developing innovative technologies to make the home wind turbine viable. One company that manufactures vertical wind axis wind turbines has made a name for itself in the United States is Icewind. It offers two main models, CW100 for domestic wind turbines and RW100 for industrial wind turbines. Nevertheless, there's a big difference in cost and stress between the two. Another well-known name is the wind turbine based in Archimedes thrust. Developed by the Dutch company, the Archimedes, this turbine consists of 3 circular blades that are wrapped around each other in the other expansion that makes it look like a rose. Thanks to this technology, it captures about 35% of all kinetic energy. Its big advantage is that it's quite silent, generating less than 45 decibels, and it can produce electricity with wind speeds as low as 0.9 meters per second, which is very low compared to other models on the market. Although it is promising, the company is still in the testing phase, so it is not for now. According to the company, a 1 kilowatt wind turbine can produce 1,500 kilowatt hours in 1 year at wind speeds of 5 meters per second. The third type of blade on-ridge wind turbine. In the United States, they are manufactured by Ontario-based Power Collective. This technology takes advantage of the wind's focusing effect, which forces the wind to move across the roof surface by forming a pitch point at the roof's crest. This accelerates the airflow through the turbine 3 times more. However, it must be installed in places where airflow is likely to occur. The blade on a ridge can be produced up to 9 times more energy than the traditional horizontal axis wind turbine. It can operate with very high efficiency from 0 to 45 degrees in a bi-directional way and can resist turbulence. In addition, it is silent and vibration-free. The blades are self-regulating, and spacing between them results in the flow separation at high wind speeds, so the system does not require external or mechanical braking systems. The ability to protect itself during high wind events, like storms, is a very important feature. In the US, designer Joe Dunsey created the wind wall, based on 25 generators with blades rotating in the middle. The wall is 2.4 meters high and 7.6 meters wide. It can produce up to 10 kilowatts, but the design can be customized for each client. This means that about 84% kilowatt hours per day can be obtained. While it looks cool, this technology is still in the design phase, and its effectiveness in urban environments has yet to be proven. The sheer size of the wind turbine also limits its application. The outlook for micro wind turbine sector, it is clear. It is not super positive. This market was valued at $277 million in 2020, and it is expected to grow at a rate of about 1.4% between 2022 and 2027. This is extremely low compared to the solar panel market. In fact, the solar panel market was valued at $170 billion in 2020 and is expected to reach about $293 billion by 2028. For most of us, it's cheaper and easier to add a few more panels to our roof and leave it at that. Its performance makes the most cost-effectiveness and least maintenance-intensive solution. That's it. We've reached the end of the topic for today. If you enjoyed this video, please give it a little thumbs up. Make sure you don't miss our next topic. Feel free to subscribe to the channel, and don't forget to turn on the notification bell. Thanks for sticking around to the end of the video, and we'll see you soon on aTech.